whenever you graph what would be considered like a general rational function, okay, you had the standard one yesterday to where you either had it in like where you had a constant over a function and then plus or minus something on the back end, as far as whether it went up, down, things like that. Then you had functions to where it was just a single function where nothing would have been squared, nothing. It was just a standard like linear function over another linear function, and you graph that. Whereas today what you're going to have is you're going to be dealing with values that will be possibly quadratic, either in the numerator spot or the denominator or both. There are essentially three types of these. One, like I said, you've already done or very similar to that. So what you have at the top of the notes is kind of the steps that you want to go about any of these functions. So the first thing you want to do is find the x-intercepts. Okay, you may only have one x-intercept. Okay, you're going to set the numerator equal to 0. That's going to be one of the easier things to do. From there, then what you want to do is find the vertical asymptote. So you're going to set the denominator equal to 0. So regardless of which part you have, you're going to set the numerator equal to 0 and then the denominator equal to 0. That will find your x-intercept and your vertical asymptote. From there, then it's kind of a case-by-case basis as far as what type of rational function am I dealing with. Okay, so if you notice as far as the horizontal asymptote, okay, like I told you yesterday, you're either going to have a horizontal asymptote or a slant asymptote. Everything yesterday had a horizontal asymptote. Today can have what's called a slant asymptote or an oblique asymptote. They mean the exact same thing. So then what you want to do, so the first thing we do, find the intercept, find the vertical asymptote. Then for the horizontal asymptote, you really want to see one of three things. Either the top degree is going to be less than the bottom, then it's an automatic horizontal asymptote is equal to 0. If the top degree and the bottom degree are the same, then it becomes like what you did yesterday where you put the lead coefficient of the top divided by the lead coefficient on the bottom. If the top degree is greater than the bottom degree, then there is no horizontal asymptote. That's where you will then go to step 4. There are basically case by cases where you may not go to step 4. You may go 1, 2, 3, and then go to 5, and then go to 6. The only time that you will go from 3 to 4 is if your top degree is greater than your bottom degree. Okay, then you will go from 3 to 4. If not, if it basically fits any of the other two, you're going to go straight from 3 to 5. Okay, you're just going to skip step 4. Because if you have a horizontal asymptote, you can't have a slant asymptote. So it's going to be similar to what we did yesterday. Then you just go 5 and 6. Now, the one thing it does tell you about the oblique asymptote is that these will only occur if the top degree is 1 greater than the bottom degree. Everything you have will be, if it is going to be oblique or a slant, it will only be 1 degree bigger. Okay? It says you can use long division and ignore the remainder. I'm okay with you using synthetic just because it's going to be just as easy. Okay? If that's how you want to do it. If you want to use long division, in some cases, like if it's an x to the third over an x to the second, then long division might be the better way to go. So if we go with just the first one here, so it says x over x squared plus 2. So if we follow basically our steps, first thing we need to do is find, we're just going to basically go down the list. There's 1, there's the second thing. Here is going to be 3, and then this is basically 5 and 6 as far as our steps are concerned. So first thing we have to do here is what? Find the x-intercept. So what do we need to set equal to 0? Set the top equal to 0. So x is equal to 0. Do I need to do anything? Nope. X is equal to 0. What's the second thing that I need to do then? For the vertical asymptote, what gets set equal to 0? The denominator. So x squared plus 1 equals 0. So then if I have x squared equals negative 1, I have the square root of negative 1, x is equal to plus or minus I. So is there any sort of vertical asymptote? No, nothing you can see. Okay, so you can put, like in this case, there wouldn't be one. If you get anything imaginary, there's not one. Your third step then becomes, which one is it going to apply? Does it fit like of 3, does it fit the A, the B, or the C? Is the numerator, is the top power, is it less than, is it the same, or is it greater than the bottom side? It's less than. So then what is, if I'm looking right here, if the top's less than the bottom, do I have a horizontal asymptote, or am I going to go down with the oblique asymptote? Horizontal. So then what is my horizontal asymptote? What is y equal to? What did it say in the little box right above it? On step 3, you have 3 little 0. How do you know that? Because it tells me that, right? Everything that you're given tells you what you need to do. You look at the two powers, the greatest power on the top and the greatest power on the bottom. You have x to the first on top, you have x to the second on bottom. 1 is less than 2. So then it fits that first kind of bullet there. Every time, if the top power, or the top degree, is smaller than the bottom degree, it is going to be y equal to 0. Since I have a horizontal asymptote, then I do not have an oblique asymptote. One of these two here will be filled in. The other one will be none, not applicable. Don't just leave it blank, put something in there. Okay? None is better than just blank, because then it's like, and don't just put something in there because you think, oh, there's a blank, so I've got to fill it in with something. None or non-existent or NA is perfectly fine. So then from here, if I'm going to graph my asymptotes, I have a horizontal asymptote here. Now, I don't have a vertical asymptote. Okay, because it's imaginary, so that's not going to be necessarily the case. So since there is not a vertical asymptote, what's my domain going to be? Where's it going to go from? Negative infinity to where? Positive infinity? Because there's no restriction as far as my x value. What's my range going to be? Range deals with the horizontal asymptote. So just like from yesterday, negative infinity to where? 0. And then from 0 to positive infinity. Next thing then is going to be your graph. If you have a graphing calculator and you plug everything in, what do you notice about it? Huh? It's an X? No? Oh, one of those things I've done before? Looks something like that, kind of. Okay. That asymptote, as far as your values are concerned, okay, your asymptote, it's going to run along that line. It just has a little bit of a blip kind of there in the middle because everything gets somewhat bigger or somewhat larger in there.